Somewhere in a distant galaxy, a star is being torn apart. Stretched, shred, consumed. Its gas drawn out into a spiral of superheated light. For a few weeks, that dying star blazes brighter than 10 billion suns. This is how we usually find the invisible, a black hole, betrayed by the last star it ever ate. But this one is different, because it's happening in the wrong place. Not at the center of the galaxy, where black holes are supposed to live. 30,000 light years out, in the cold, empty dark at the galaxy's edge, there's a giant hiding out there, silent, starless, and it just made its one mistake. Almost every large galaxy has a monster at its heart, a supermassive black hole, millions, sometimes billions, of times the mass of our sun. At the center of the Milky Way sits ours, Sagittarius A star, about 4 million solar masses. They range enormously. At the extreme sits Phoenix A, one of the largest black holes ever found, with estimates running up to a staggering 100 billion solar masses, tens of thousands of times heavier than our own. Galaxies are built around these giants. Gravity gathers them at the center, but a black hole gives off no light of its own. So how do you find something invisible? You wait for it to feed. When a star drifts too close, the black hole's gravity doesn't pull on it evenly. The near side is yanked far harder than the far side. That difference, the tidal force, stretches the star into a thin stream of gas. Part of that stream falls inward, whipping around the black hole, heating to hundreds of thousands of degrees, and erupting in a flare that can outshine the entire galaxy around it. Astronomers call it a tidal disruption event, a TDE. They are staggeringly rare. On average, a given galaxy shreds a star like this just once every 100,000 years. Over the last decade, we've caught more than 100 of them, and nearly every single one happened exactly where we expected. Dead center, until one didn't. Late in 2025, a survey called the Zwicky Transient Facility was scanning the sky, catching anything that suddenly brightened. That flood of data is far too vast for human eyes. So the search is run by an algorithm, a machine learning classifier trained to recognize the distinctive signature of a TDE, the precise way its brightness climbs and fades, its light curve. But that classifier had always carried a hidden assumption baked in, that black holes sit at galaxy centers, so it only ever searched the cores. A team led by astronomer Robert Stein rebuilt it. They stripped out that assumption and told it to look everywhere else. The outskirts, the edges, the dark. Starting in August 2025, the retrained AI flagged a handful of ordinary TDEs at galaxy centers. And then it found one that wasn't. A flare sitting so far out that, in Stein's words, you couldn't even see the galaxy anymore. They named it TDE 2025 ABCR. When they measured the gap between the flare and the center of its host, a massive galaxy in the constellation Cetus, the number was staggering. 9 1/3 kiloparsecs, roughly 30,000 light years. The farthest a tidal disruption event has ever been found from a galaxy's center in visible light. A flare in the wrong place is thrilling. It's also suspicious, because other things flare, too. An exploding star, a supernova. So can a feeding black hole at a galaxy's core, an active galactic nucleus. To be sure, the team split the flare's light into a spectrum, a barcode of the elements glowing inside it. And there it was, broad emission lines of hydrogen and helium, smeared wide by gas racing at thousands of kilometers a second. The classic fingerprint of a star being torn apart, a TDE rich in hydrogen and helium. A supernova would have shown the wrong elements. An active nucleus would have shown lines far narrower, in the wrong pattern. telescopes on the ground and above it. SOAR, the Lowell Discovery Telescope, and later the James Webb Space Telescope and Keck, all confirmed it. At its peak, this one dying star briefly outshone its entire host galaxy in ultraviolet light, blazing with the power of roughly 10 billion suns. And when they weighed the black hole behind it, the story turned stranger still. The galaxy's own central black hole is a heavyweight, around 660 million solar masses. But the one out in the dark, the one that ate this star, is only about 1 million times the mass of our sun. A true supermassive black hole, yes, but a lightweight. It's a few times smaller than the giant at the Milky Way's heart. And it was nowhere near any galaxy's center. So what is a millions solar mass black hole doing 30,000 light years from home? There are two possibilities, and here the science is still open. The first, it was thrown there. When two galaxies collide and their central black holes spiral together, a third can be flung outward like a stone from a slingshot, kicked clean out of the core, left to drift through the galaxy's outer halo. The second, it never belonged to this galaxy at all. It may be the dense heart of a much smaller dwarf galaxy, one that strayed too close and is being slowly torn apart, stripped away until only its central black hole remains, coasting through the bigger galaxy's suburbs. Both point to the same deep truth about how the universe is built. Galaxies don't grow alone. They grow by devouring one another, merger after merger, over billions of years. And every time two galaxies merge, their black holes are supposed to sink together into the center. But theory has long predicted that some never make it, that they get stranded, wandering the halo, a hidden population of dark, drifting giants that no telescope could ever see. For decades, those wanderers were only a prediction. TDE 2025 ABCR is one of them, caught in the single instant it gave itself away. Here's what makes this more than a curiosity. A wandering black hole is almost always completely invisible, unless, by pure chance, a star strays close enough to die, which means for every wanderer we catch mid-flare, there are countless others we've never seen. But that's about to change. This detection proves that ordinary ground-based telescopes, not just X-ray observatories in space, can spot these offset flares and pull wandering black holes out of the dark. And a new generation of survey telescopes is coming online. Astronomers expect hundreds, maybe thousands, dozens of them offset out in the halos, each marking a wanderer. Everyone is a fossil of a collision, a black hole that survived the merger of galaxies and never found its way home. Map enough of them, and you map the violent history of how galaxies and the universe's entire large-scale structure were assembled. So it's not that a black hole appeared where it shouldn't be. It's that it was always there, silent, dark, and drifting, exactly as the theory said it might be. We simply had no way to see it, until it tore apart a star 30,000 light years from the center of everything, and until someone was finally willing to stop, assuming they already knew where to look. There are dozens more out there in the dark. Now, at last, we know how to find them. Follow for more mind-blowing space facts.